All right, so today we're diving deep into G&M code, the language that basically brings CNC machines to life.
It's like composing a symphony, but for physical objects instead of musical notes.
Yeah, exactly. And our sheet music for this deep dive is the Mach 4 G&M code reference manual. We'll break down even the most complex stuff, so don't worry.
It can seem intimidating at first, but we'll make it digestible.
Yeah, and get this, you can even program the machine to think like it's using a compass and a protractor.
That's right, using polar coordinates.
And there are these cool shortcuts called CAN cycles for common actions like drilling and tapping. Super handy.
It's amazing how G&M code blends precision engineering with computational thinking.
So it's more than just telling a machine move from point A to point B.
Oh, much more. It's about translating human intention into a language the machine understands. Think of it like a recipe where each line of code tells the machine exactly what to do and how to do it.
Okay, I'm starting to get the picture. So first up, G-code. What's the deal with this motion master?
Well, G-code orchestrates every move the machine makes, from those rapid traverses between cuts to the precise movements that actually shape the material. It's all about relative motion.
Relative motion.
Yeah, the code tells the tool where to go in relation to the workpiece,
Yeah.
even if the workpiece itself is moving.
Whoa, that's cool. But how does the machine know which way is up, down, left, or right?
It uses a coordinate system, kind of like what you learned in geometry class, right?
Yeah.
X, Y, and Z axes.
Oh, yeah, vaguely.
Well, the right-hand rule is a great way to visualize this. Imagine pointing your thumb, index, and middle fingers to represent the X, Y, and Z axes.
Okay, I'm doing it. So if I want the machine to move to the right, it's moving along the positive x-axis.
Precisely. And G-code lets you manipulate those axes with incredible precision. Take G09, for example. That's the exact stop command.
Yeah, the exact stop. Why would you need that?
Imagine you need a perfect sharp corner on a part. Let's say for a sleek new phone case. Without G09, the machine's momentum might round the corner slightly.
Ah, I see. So it'd be a little bit rounded.
Right. But with G09, it ensures a complete halt at that corner point, guaranteeing a perfectly sharp edge.
That level of control is pretty impressive. Are there any other G codes that stand out as particularly useful or unique?
Well, there's G16, which allows you to program the machine to understand polar coordinates. Instead of moving to a specific XY coordinate, it moves a certain distance at a specific angle.
So it's like switching from a grid system to a compass and protractor.
Exactly. And that makes programming parts with curves or circular patterns much easier. Like imagine designing a fancy bottle opener.
Yeah, that would be a lot of curves.
You're essentially speaking the machine's language more efficiently using polar coordinates.
That makes sense. So are there any other cool G codes?
Oh yeah. There's G51, which lets you scale toolpaths up or down. Imagine you've designed a phone case, but then you need a larger version for a tablet.
Would you have to redraw the whole thing?
You could, but with G51, you can just resize the entire program, saving potentially hours of work.
Wow, talk about a time saver. And this scaling works for complex shapes too, or just simple ones.
It works for both. It's super versatile. And then there's G68, which rotates the entire coordinate system. It's like physically rotating the workpiece within the machine, but you do it all through the code.
So no more manually rotating the part?
Nope. It's incredibly useful when working with angled or skewed parts. Like if you were making a custom angled phone stand.
That would be a game changer.
Absolutely. You can achieve complex orientations without physically manipulating the workpiece. It gives you so much more flexibility in your design process.
All right, so G-code is definitely the boss when it comes to motion. But what about everything else, like tool changes, coolant spindle control? Does G-code handle that too?
That's where M-code steps in. The multitasker, it handles those auxiliary functions and even manages the flow of the program.
So it's like the conductor of an orchestra, making sure everything happens in sync.
A perfect analogy. Some M-codes are standardized across different machines, which helps with compatibility.
So you can use the same code on different machines.
Sometimes, yeah. But there are also machine-specific M-codes that unlock custom functions, making each CNC system even more versatile.
Okay, I'm dying to know more about these M codes. Can you give me some examples? What kind of cool things can they do? So give me the lowdown on these M codes. What can they do?
Well, there's M00 for starters. It's like hitting the pause button on the program. It halts a motion, and spindle rotation gives you a chance to make checks or adjustments. Think of it like a built-in safety check in the middle of a complex manufacturing process.
So it's like a timeout for the machine to make sure everything's running smoothly.
Precisely. Especially in industries where precision is critical, like aerospace manufacturing, you really don't want any mistakes. Then there's M30, which signals the end of the program. It rewinds it back to the start, kind of like hitting play again on an old cassette tape.
So it's like that's a wrap signal.
Exactly. It tells the machine, okay, this job is done, you're ready for the next one. And then there's M98, which lets you call subprograms.
Subprograms, like mini programs.
Exactly. Think of them as little recipes for frequently used tasks. It keeps your main program clean and easy to understand, which is crucial when you're dealing with complex manufacturing processes.
So instead of repeating the same code over and over, you can just call up a subprogram.
Precisely. Much more efficient. And speaking of efficiency, we touched on CAN cycles earlier. What makes them so special?
Yeah, those shortcuts. Tell me more about those.
Well, CAN cycles are like prepackaged routines for common actions, like drilling, tapping, boring. They drastically reduce the amount of code you need to write, which makes programming much faster and more efficient.
So it's like having a shortcut button for those everyday tasks.
Exactly. Imagine you're in an industry like automotive manufacturing, where you might be drilling hundreds or even thousands of holes in a single part. CAN cycles are a lifesaver.
Okay, so walk me through some of the most commonly used ones.
Sure. Let's start with G81, the drilling cycle. This one is all about simplicity and efficiency. You specify the hole location, depth, and feed rate, and the machine handles the rest. Moves to the position, drills down to the depth you specified, and then rapidly retracts.
Sounds pretty straightforward. What about those really deep holes that need a bit more finesse, like drilling into a thick piece of metal for a bridge support?
For those, you'd use G83, the peck drilling cycle. Imagine drilling a deep hole all in one go. The chips would build up, the tool might overheat. You could end up with a really inaccurate hole.
So peck drilling is like taking breaks to cool down and clear out the debris.
Exactly. The tool drills down a short distance, retracts slightly to clear the chips, and then plunges again. This process repeats until the full depth is reached, resulting in a much cleaner, more accurate hole.
Gotcha. So it's like a slow and steady wins the race approach.
You got it. And then there's G84, the tapping cycle, which is all about creating those spiral threads you find in screws and bolts. It's a pretty delicate process that requires precise synchronization between the spindle rotation and the linear movement of the tap.
So G84 is like a built-in expert thread maker.
Exactly. With G84, you don't have to worry about those complex calculations or timing. The CAN cycle handles it all, ensuring perfectly formed threads every time.
These CAN cycles sound incredibly useful. Are there any other favorites you want to highlight?
Oh, there are plenty. G85 is a boring cycle. It's often used to enlarge or smooth out existing holes. Think of it as a finishing touch for creating precise fits in machine parts. It feeds down to the specified depth and then retracts at a controlled feed rate, ensuring a smooth and accurate finish.
So it's like a digital version of a fine-tuning tool.
Exactly. It's all about achieving that level of precision that's often required in high-performance applications like aerospace or medical devices.
Okay, CAN cycles, definitely a must-have for any CNC programmer. But I'm curious, are there any less common but equally fascinating aspects of G&M code that you've come across in the manual?
One thing that always fascinates me is the level of control you have over program flow. It's not just a linear sequence of commands. You can introduce loops, conditional statements, even jumps to different sections of the program.
Wait, loops and conditional statements, that sounds like full-on computer programming.
It is very similar. And that's what gives G&M code its real power. You can create programs that respond to different inputs, make decisions based on sensor readings, adapt to changing conditions. Imagine a machine that automatically adjusts its cutting path based on the hardness of the material it's working with.
That's amazing. So it's not just about telling the machine what to do, but giving it a set of rules to follow and letting it figure out the best course of action.
You got it. And that's where macro programming comes in.
Okay, macros. I've heard that term before, but never fully understood it. What are macros in the world of G&M code?
Think of macros as mini programs within your main program. They let you encapsulate complex sequences of commands. Give them a name, and then call them up whenever you need them. It's like creating your own custom G&M code functions.
So you're basically building a library of reusable code snippets.
Exactly. And this is incredibly powerful. Let's say you have a complex tool change routine that involves multiple steps. Instead of repeating those steps every time you need to swap out a tool, you create a macro for it and call it up with a single command.
So that not only saves time, but also reduces the chance of errors.
Absolutely. And macros can do more than just simplify repetitive tasks. They can introduce logic and decision-making into your programs.
Can you give me an example of how that would work?
Sure, imagine you want the machine to perform different actions depending on the thickness of the material it's working with. You could use a sensor to measure the thickness, and then based on that reading, call up a different macro for each thickness range.
So it's like giving the machine a set of if-then-else statements, just like in a regular computer program.
Exactly. That's what makes macro programming so powerful. You're not just defining a series of actions. You're creating a flexible, adaptable system that can handle a wide range of scenarios.
This is mind-blowing. It's way more than just telling a machine to cut a straight line or drill a hole. It's like unlocking a whole new level of manufacturing intelligence.
And that's what's so exciting about G&M code. It's this language that blends precision engineering with computational thinking, allowing you to create truly sophisticated manufacturing processes.
It's like we've gone from learning the alphabet to writing poetry in just a few minutes. But before we get lost in the code, remind me, what's the big takeaway here? Why should someone care about mastering G&M code?
Yeah, it feels like we've covered so much ground already, from G&M codes to CAN cycles and now macro programming. But seriously, why should someone invest their time in learning all of this? What's the benefit?
Well, it's valuable even if you never actually program a CNC machine yourself. First, it gives you this new appreciation for how everyday objects are made. You know, that phone in your pocket, the car you drive. G&M Cloud was probably involved in shaping those intricate parts.
So it's like peeking behind the curtain of modern manufacturing. Exactly. And second, it opens up possibilities for creativity and innovation. If you can dream it, you can probably program a machine to create it, from custom furniture to artwork to prototypes for new inventions.
You're not just a consumer anymore, you're a creator.
Precisely. And finally, even if you're just working around CNC machines, understanding the code helps you communicate better with programmers, troubleshoot problems, make smarter decisions about the whole manufacturing process.
So it's about being more informed, more hands-on in the world of making things.
Yeah, exactly. Think about it. Knowing G&M code is like having a superpower in a world that's becoming more and more reliant on automated manufacturing.
Okay, you've convinced me. I'm ready to dive headfirst into that Mach 4 G&M code reference manual. Any last words of advice before I do?
Just remember, G&M code is all about communication. It's about translating your ideas into a language that machines can understand. So don't be afraid to experiment. Test your limits and see what you can create. The potential is truly limitless.